Let's solve some problems here on arithmetic sequence. We've already discussed how to find the common difference in arithmetic sequence, how to identify whether a sequence is an arithmetic or not. And now we're going to learn on how to find the next term, the explicit formula and the recursive formula. So let's try solving some problems here. So we're given here an arithmetic sequence, which is -14, 186, 386, 586. Okay, we're given here 4 terms in this arithmetic sequence. So we need to find the 52nd term, the explicit formula, and the recursive formula. So before we find the 52nd term, let's write the explicit formula and recursive formula first. So the standard explicit formula, okay, is just a sub n equals a sub 1 plus n minus 1 times d. So our a sub n here is our nth term, unknown. This one, a sub 1, is our first term, and n is the number of terms. And d is the common difference. And then our recursive formula can be written as a sub n equals a sub n minus 1 plus d. Again, our a sub n here is the nth term. Okay, our a sub n minus 1 is the term before the nth term, or the last term. The last term given, and d is the common difference. Okay, let's solve this problem here, the sequence here. So the first thing we do is find the common difference. Okay, so let's find the common difference of the sequence here. Okay, that would be 186, the second term, minus the first term, 186 minus -14. So this is 200. And the second term is 200 as well. And then the third common difference is 586 minus 386. So this is also 200. So our common difference is 200. Now to find the 52nd term, so we denote this as a so 52. So we can use the explicit formula. Since we're given here a first term which is equal to -14, so we can use the explicit formula. Okay, we can use this formula: a sub n equals a sub 1 plus n minus 1 times d. So our a sub n is a sub 52, our a sub 1 is -14, plus n minus 1 is 52 minus 1 times d is 200. Okay, let's simplify that. negative 14 plus, this is 51. 51 times 200 is, what is 51 times 200? Okay, so that is 10,200 plus negative 14. So we have our 52nd term is equal to 10,186. So we already have our 52nd term, and now we need to write the explicit formula and the recursive formula for this sequence. So, okay. So we already have our D, which is 200, our A sub 1, which is negative 14. Now to write for the explicit formula, so explicit, okay. So the standard explicit formula is just A sub n. A sub n equals A sub 1 plus n minus 1 times D. So we just plug in our A sub 1 and D here. So A sub n equals negative 14 plus n minus 1. Our D is 200. So we can simplify this. Negative 14, we distribute 200 to n minus 1. So that is plus 200 n minus 200. And then we group like terms, negative 14 and negative 200. So that is A sub n equals negative 14 plus negative 200 is just negative 214 plus 200 n. So this is our explicit formula. Now we need to write our recursive formula. Okay, the standard of recursive formula is just A sub n equals A sub n minus 1 plus D. So all I have to do is just plug in the value of D, because we don't have the value of A sub n and A sub n minus 1. So that will be A sub n equals A sub n minus 1 plus 200. So this is our recursive formula. So let's try another problem here. So we're given this arithmetic sequence 5, negative 195, negative 395, and negative 595. So first we get our common difference, that is negative 195 minus 5. So this is negative 200. Okay, negative 395 minus negative 195. So this is negative 200 again. This just proves that this sequence is an arithmetic sequence. So the next one is 595 minus negative 395. So that is negative 200. Therefore, our common difference D is equal to negative 200. Now let's solve for our 52nd term. The same method we used in the previous problem. So A52. So we use the explicit formula here. So A sub n equals A sub 1 plus n minus 1 times D. So our A sub 1 here is 5. So A52, our 52nd term, is just equal to 5 plus 52 minus 1 times negative 200. So let's simplify that. So this is 51. 51 times negative 200. So this is negative 10,200. So 5 plus negative 10,200 is just negative 10,195. Therefore, our 52nd term is negative 10,195. Now to write our explicit and recursive formulas. Okay, so explicit formula. A sub n equals a sub 1 plus n minus 1 times d. Again, we just plug in our a sub 1 and d here. So a sub n is just equal to 5 plus n minus 1 times negative 200. Then simplifying this would be 5 plus negative 200n plus negative 1 times 200 is 200. So by grouping like terms, this would be 205 minus 200n. So this is our explicit formula for this arithmetic sequence. And now for our recursive formula. Recursive. So this is just equal to a sub n equals a sub n minus 1 plus d. Again, we don't have the value for a sub n and a sub n minus 1. So we just plug in our d, which is equal to negative 200 in the formula. So that would be a sub n equals a sub n minus 1 minus 200. So this is our recursive formula.